Hello everyone again, and welcome to my second live stream. So I got rid of my TV in the back, and there are some plants now. Nothing fancy, but yeah, I think it should be fine. Also, yeah, in this time, an idea is to figure out how to run the PageRank algorithm by using Python. So it's going to be super simple. So we're gonna just try some basic PageRank stuff and explain a bit theory, super basic and super simple. And yeah, and then we're gonna time a bit and figure out what is the actual time needed, and yeah, mostly I'm gonna focus on PageRank only in this video. Yeah, if you have any questions or anything similar, just put them in the chat below, and yeah, I try to answer as fast as possible. So yeah, let's if you have chat is there. I think everything should be fine so far. Three viewers, so that's great. So I'll just jump to the code. So okay, let's do. I'll try to continue the work from the previous sessions, and yeah, just to expand a bit, and yeah, that's how it should usually be, because there is a bunch of stuff, and yeah, that all can be extended in a nice way. So let me just jump into the code that we did last time. So we have here the live stream folder. That's a repository on GitHub, where I'll push all the old code and then link that in the videos on YouTube. Yeah. So I'll just simply copy the folder and put it as this date. Okay, let's move in 3. Okay, and then as usual I'm going to use Tmax and Vim mostly for all the code editing and running stuff. So I'll just name this let's do it like this. So okay, here I'm gonna, okay, let me put it here. So here we're gonna have the code. Let's open the setup. So that's what we already have in the whole thing, but it's fine. So now we have here the run part, and maybe we also need Memgraph somewhere to be up and running. And just for the sake of completeness, last time I forgot to make the list of all requirements in this repository. So this time I'm gonna do that just a bit quickly. So Python 3 and yeah, so we only needed PyMG client, even though I might not need this this time, but yeah, let's just activate. Let's activate that and install PyMG client. Great. And yeah, freeze. So that will just freeze all the requirements. So yeah, that's great. What we also need is Memgraph up and running. So we're gonna do last time I promised I'm gonna do Linux native install, but I'm gonna skip that for now because Docker is still a really good option, and since I'm gonna focus more a bit on the algorithms, so we're gonna do that at some point later on a live stream. So yeah, Docker run minus rm standard stuff minus p. So okay, we have Memgraph instance up and running, and what else do we need? I think we just need Memgraph lab. That's super useful to have in order to visualize stuff. Okay, so at this point we have all the repo defined, so and ready to start. So I'm gonna just prior to jumping into the whole like way of running PageRank and explaining that, I'll just quickly explain what the PageRank is and give a little bit of overview. Just whoever is not aware of the PageRank, just to be familiar at least with the basic idea. So let's Google a bit first. So PageRank examples. So there is a nice page on the web. I think here is the actual link where PageRank that explains the PageRank algorithm. So this thing is fairly simple, but yeah, overall an idea of a PageRank is to provide importance of nodes in a graph. So whenever you have a network structure where the nodes are interconnected and where you have like the similar entities in a graph, you can calculate the importance of each node just based on the number of connections between them, on the number of edges. And and then basically PageRank is an iterative algorithm that calculates that eventually comes up with a rank of each node in a graph. So here there is a formula so that says how to calculate a PageRank of a page A. And yeah, don't be scared here. Page could be anything. So page is just an abstract term that can be almost anything. So whenever you have a network structure and nodes are connected, PageRank could be calculated, and yeah, it might be useful. So just to decouple this formula a bit, I've prepared simple visualization. Maybe that's gonna help. And yeah, so and also when I prepared a bit today, so I stumbled upon a nice tool which is called Gnome Draw or something. Let me start it. So Gnome Draw Screen or something like that. Let me Google that because I forgot the actual name. Oh, I'm not yet skillful. No, draw on screen. So it seems my internet is a bit slow. Should be anyway. Okay. So this is a GNOME extension that essentially allows to draw stuff on the screen. It's very simple, and these things could be just deleted easily, and then I can go back into the normal mode. So yeah, I'm using this to draw a bit over my screen at the same time. So let's close this and go back to this one. So essentially, let's go into the drawing mode again. So this formula here says essentially for the calculate me a page rank of a page A, and do that in the following way. So the first part here is not really really critical. It's just some statistical trick that ensure that like the results will be summed to 1. So nothing really fancy here, and the D is constant, and it's usually 0.85. So it's just set in the usual calculation. But apart from that, the rest is interesting. So so in order to calculate a page rank of a page A, that's done by just summing, like make a sum of page ranks of all sites that are of all pages that are pointing to that page A, divided by the number of outgoing links. So these here are, let's say, outgoing links, and the page rank for the page T is divided by that number. And essentially, that means if page T has a bunch of outgoing links, then this link here is not that important in the overall overall view, and it should this link from T1 to A should mean less if T1 has a bunch of edges, a bunch of outgoing edges. And yeah, it's simple as that. So you have to make a sum of all these page ranks divided by the number of outgoing edges, and that's basically it. So maybe just if you take maybe just a note on that side, if you take for example a graph at a certain point in time, then these number of outgoing edges are constant numbers. So each node has a constant number of outgoing edges at any given time. So that can be used since PageRank is an iterative algorithm, and you have a bunch of iterations, then it makes sense to cache these numbers. But yeah, in this video I won't go into that optimization. But yeah, that's a nice property of the whole thing. Okay, let me go back to the normal mode, and yeah, since I've explained a little, I've tried to explain the algorithm, at least super basic idea. I'll try to run it in Memgraph. So let me close this. I think we won't need this anymore. I'll also close this. This site also has a bunch of small examples that could be used. So just to verify that we can run PageRank, I'll just use this super simple example first, and then we're gonna move to more interesting examples. So okay, let's go to the lab and let's create that graph. So we can do that by running a simple query. So page A, where the name is page A, and then we have another page B, which is also page, and the name is page B, and we can create connections between page A and let's say a link, and page B. And we also, so in the initial example, there is a link between page A and page B, and also a link back to the page from page B to page B to page A. So we're gonna just copy this and just reverse this. Page A, okay. So now the graph, let's verify that quickly. So match N. So N R M R M M. This is a super simple query that just returns all the nodes and edges. And usually, if you want to fetch all this, you can just specify this query. It's very memorable and it's very useful. If you have a large data set, then it's also useful to put here some kind of a limit. Let's put just 10 here for now, but that will limit the number of nodes and edges, because otherwise it's hard to visualize a bunch of nodes. So here we have page A and page B, and we have links between. So let's try to calculate PageRank of this. And since, I mean, we would need to implement PageRank somehow, but Memgraph already comes with a module that wraps NetworkX Python implementations, and we're gonna use that to run the algorithm. And maybe to just recall a bit. So if we call mg.procedures and yield them, we have a bunch of them here. But yeah, let's find the PageRank exactly. So I'll try to do that with a query. So we have name and signature. So I'm gonna take everything from here and write here with name. So that will take name and signature out of all the symbols that are defined before and apply the filter. So where name equals to I think nxalg.pagerank, and then return name and signature. So if I run this query, I'm gonna get only PageRank, which is exactly what I wanted. So, and here you can see the parameters of every PageRank call. So there is that argument alpha, which is a D. So from the formula before, that's exactly D. And there are some other flags. Since that's just proxied NetworkX, I'm gonna go back to I'm gonna go to NetworkX just to quickly go through these parameters. NetworkX, okay. Nope. PageRank. So this is an older, whoop. Okay, let's find the PageRank. Maybe I can do that. And here we have a couple of functions, but I think this one is only one that is interesting. So here we have a bunch of stuff. So PageRank is getting the PageRank method is getting a graph, and then alpha, and some other advanced parameters like personalization, where you can specify the values of each node, I think. Yeah, you can specify the values of these ranks up front. max iteration. Because PageRank is an iterative algorithm, you also specify how many iterations do you have over the whole algorithm run. Some error tolerance and starting value of PageRank iteration for each node. Weight. So PageRank also supports weights, so you can have a weighted PageRank. But yeah, I'm not covered. I'm not gonna cover this this time. And dangling the out edges to be assigned to any dangling nodes. If a node doesn't have any out edges, then you can assign values to that node. So by default, it is. But yeah, anyway, so this is a bunch of flags. We're gonna do only basic stuff here. So let's go back. Let's go back to the Memgraph. We might go back here at some point, but let's for now just run the algorithm to see the results. Okay, and if we do call nxalg.pagerank and we run, we just yield everything. We're gonna get, so page A has a PageRank 0.5 and page B has a 0.5. In this case, that makes total sense because all the pages are equivalent. They both have the same number of links, and in total, this implementation of PageRank returns ranks. If you sum all the returned ranks in a graph, the sum should be 1. So this is also correct here because the ranks are 0.5 both. Okay, this is fairly simple. Let's do a bit more advanced stuff. But again, it's gonna be super simple. We're gonna just, here is another. So this site, thank you to Ian Rogers, has a bunch of these examples, which are super simple and yeah, could be used to understand the algorithm in details. So I'm gonna just run this example to be more confident with the whole thing. So it is a bit more complex, so I'm gonna split my screen so that I can see what is going on. So let's create this graph here, and yeah, page A, which is a page A, page B, name the page B. Okay, let's quickly copy paste this. C. I think this should be correct. And let's create these links. So page A is connected to link. So this is a convenient way of creating simple datasets because in a single query you can reference all these created nodes, and it's super simple to create to deal with small datasets. So page B, page A is also connected to page C. So that's done. That's done for that. Let's do page B is only connected to page C. Page B, page C. Okay. Page C is connected to page A. 1, 2, 3, 4. That's fine. And then the last one is page D is connected to page. Oh no, page B is connected to page C. Okay. I think so. Let's check one more time. So page A, page B, that's correct. Page A, page C, that's okay. Page B, page C, that's correct. Page C, page A, that's also fine. And D, C, okay. I forgot to remove, so I'm gonna just copy, paste, and copy, and then delete N. So now my dataset is empty, and I'm gonna go back with this query. What did I do wrong? Page A, page B, page C. Four, 1, 2, 3, 4. Line 4, 8. Page C, page. I'm missing this here. Okay. So now let's go back to the graph. So if we take this here, let's do it in the same. So yeah, page B is connected here, C, and we have this here, which is fine. So yeah, I think the graph is fine. And let's then rerun the PageRank. So let's go under data because we have the numbers here. So we don't need this anymore. So let's go back here. So as you can see, we have slightly. So let's go back here because there are some page ranks here. So let's return it. So page A, page B, C, and D. These ranks are a bit different, but they are just normalized. So nothing really is different here because obviously page C has the biggest page rank, and that's the case here as well. So it's 0.39, and it's very similar to the rank here. Yeah, basically almost the same rank. And then page B is half of that, let's say, and page D has the lowest rank because there are no other pages, there are no other nodes that are pointing to that page. So that's the least significant node in this simple graph. So I think that's enough for you to get an idea. If you have any questions, yeah, please say. I'll try to answer. Otherwise, I'm going to go further. So let me just save this somewhere. These create queries, because I think these queries are useful in general. I'm gonna copy them and go back to the code and just store them somewhere. So let's do queries folder for now. And yeah, how do we call this? Maybe, yeah, simple PageRank 1, 2. So simple 1 dot txt. So let's do this so that you can reuse them if you would like. So okay, this is a bit lab connected, all this, but yeah, I'm gonna split that. So okay, this is the first example, and the second example is lab, and this one here. So okay, and actually a simple page rank to txt. PageRank. Okay, and here we have the second example. So okay, so that, and that's fine. That's fine. And that should be fine. And we have the comma there, and yeah, we good. Okay. Okay. So now when we have that as files, we can move on. So my idea next is to run a more complex example. And yeah, I was thinking what to run, and obviously we did the MovieLens last time, MovieLens dataset, but the problem with MovieLens dataset is that we don't really have direct links between similar entities. So we have in the links, no, this is just the links to the movies. We have movies obviously and ratings, but the problem is that users make ratings of these movies, and that's basically it. There is no direct connection between users, let's say, even though we might construct something that might be actually interesting to construct some I don't know, a network of users based on the movies they watched, but this is not useful as is, so we have to do some changes. And the MovieLens dataset is actually more suitable for other graph algorithm, which is called collaborative filtering, because it's let's say it has that format of two entities that are connected between each other. So the movies and the users, or and the watchers, and that's basically very similar to the, let's say, shopping cart and the users that bought similar items. So when you have whenever you have users and items, then you can construct and run a similar graph algorithm, which is called collaborative filtering, and then get recommendations for the next purchase or so. And that's my idea is to showcase that after we process PageRank. So that's gonna come at some point later in this live stream series. So in order to, if you have some interesting dataset to run PageRank, I would like to hear that. But since we don't have that, since we can't run on MovieLens, I'm gonna just reuse the last dataset that we imported last time, the roads dataset. So I'm gonna go back into the lab and just quickly delete these small examples. And so now we should have the empty dataset, and that's fine. And last time I also I also downloaded these datasets, so I have them here. LS downloads. So the countries, PageRank, country, cities, and the roads. So I'll try to import that quickly. So let's create one more of these. So MG console is a bit more convenient and to do that. But yeah, if you remember, we also create indexes for cities and countries. So create index on city name and okay, city and country. I think we're good, and let's just quickly check. Show index info. Okay, we have the indexes, and now let's go back to the MG console, and if we get downloads, so let's do countries first, pipe that to MG console, and then we have downloads cities, and we also have get downloads roads. That will take a bit more time, but if we go back here, the dataset is getting populated. So yeah, we have almost done. So it has, the dataset has 65k pages. Yeah, that's it. So dataset is in, which is great. And in order to run PageRank, here we're gonna be a bit more advanced. So we can actually run a PageRank on more stuff. So we can run PageRank on countries and cities, and we can get various details about that. So I'll do just simple running PageRank on countries as nodes. So let's do that from here. Let's say if we run call ng and nxalg.pagerank, we're gonna do just simple statement. Yield again same with node and rank. So the PageRank algorithm returns node and rank as columns, and we can simply filter out all the country nodes by putting a filter here, and we can say labels node. So that will return, the function will return all the labels for that node, and also we can do here country. So that will filter out all the countries, and then return node and rank. That's fairly simple. And also we want to order by rank, and we want descending ranks, so that we get the most important country when it comes to the roads in general. Since I've run this query a little bit earlier, maybe if you would guess what would be the most important country based on the roads, please put your bets in the chat until I run this. And I have to also let's say I'll limit by 10, and we can also put here until, since I'm not getting any bets here, I'll also skip the first results. So let's put here, I don't know, 15. I think that should be it. So if I run this up, skip has to be before limit. Node. Sorry. That's instead we want to get labels for node, not for nodes, because we don't have nodes at this stage. So if we run this, this is gonna take a bit longer since it's implemented in Python, so it takes a bit longer. We can also go back to the to Memgraph just to quickly check what is going on under the hood. So let me do this. Docker exec. Docker exec will attach to the container bash. But yeah, since we want to install, since Docker is coming without any additional software like I don't know, htop or anything similar, we'll use here -u root. So we're gonna log in as a root user in order to install a couple of things, just to be able to visualize stuff. So yeah, we are now as a root. Otherwise, without the -u parameter, we would got logged in as a Memgraph user. And since also one thing to note, if you just run apt install, for example, the htop, we got nothing because we removed everything from the from packages, and nothing is there, and Ubuntu Debian actually is unable to run any install. But if we just run apt update, Debian will rebuild all these packages, and now you are able to install stuff inside Docker. And we can just run apt install htop. So that will run htop, and we're gonna get htop here. We can run this, and yeah, we can see here the whole all the processes and the statistics. But it seems that our algorithm is finished. So boom, we got all the countries. So we have the ranks of these countries, which is pretty good. But yeah, let's go back. Let's rerun this query again. So if we go back here, now Memgraph is doing the work. And we can I can maybe showcase here a little trick with Memgraph, a useful stuff in some cases. So if you open htop, you just see here one process of Memgraph, which is great, but super not useful because all these threads are called the same as Memgraph. So that's not very useful, but we can get more information from this just by enabling thread names, because Memgraph has set all the thread names in the code. So we can just go quickly here, and there is an option here which says show custom thread names. If that option is enabled, then if we go back here, you can see here all the thread names that Memgraph is using, so that are defined. So we have a bunch of these bolt workers, and let's go back here and rerun it again. So as you can see, now one bolt worker, which is assigned to deal with that connection, is at 100%. So the whole algorithm is like running based on this worker on inside that bolt worker. So bolt is the server, like the protocol, and Memgraph is implementing a bolt server, which serves the connections and returns the result. Okay. That's pretty fine. That's pretty good. And just for the sake of completeness, I'm gonna also measure how long does it take to calculate PageRank on this data set. So if I go back here into the console thingy, we can just do echo and then run the same algorithm and then put here mg console. Of course, to jump back. I don't know. I'll do that a bit dummy, but should work. So time. So if we just measure time of this algorithm, so it should take. We'll see how long it will take to finish. That's I think it. Let's go to Memgraph. Yeah, it's running, so okay. And yeah, we actually don't have a control over these. So the user, it does not have the control over these threads, but yeah, that's probably a nice feature to add. So yeah, it takes, so to calculate the PageRank, so on this simple dataset, it takes 26 seconds. So in the next, in the following stream, I'll try to build, and we already have an implementation that does much faster. So we're gonna showcase that. But let's go back and actually today no much engagements in the comments, but I'm gonna just put back here 0 and rerun the query. So basically that will give us the most important country based on the road connections. So we'll see that in a bit. And what else I can do? Okay, it seems to be done. And if we see, so yeah, Russia, Spain, and Italy are apparently the most critical countries when it comes to the road infrastructure. So yeah, good to know. I didn't know that prior to running this. Yeah, maybe just to maybe a useful thing here is to actually see the debug output of the whole query, because we have some kind of a filtering here and PageRank and stuff like that. So let's just if we run explain, we have pretty interesting output here. So we run call and then we produce and then we filter and then we produce again, and then there is order by and skip and limit. I assume these operators here will do very low amount of work because we have low number of country nodes, but the call should take more time. So let's try to run the profile. It seems that we have some kind of a bug here, but anyway, we'll try to rerun this a bit. Maybe actually profile doesn't work with the call. Let's just try to run. So if you go back here, it's still doing some work. Okay, let's try to play with something else. So profile match n, return n, if we run this, we got something, and if we go back and run this, yeah, it should work. That's another thing to note. Sometimes profile seems to be broken in the lab, but yeah, we'll see about that. So if we go back here, it's all fine. Okay. It's not done yet. This takes a bit longer, I think, because of the here we are. We think, but that's okay. Sorry, this took a bit longer, and then results were a bit mixed. But yeah, if we go here and see here, profile is probably taking a bit longer to calculate. So then the whole lab is just showing nothing. But if we go back here, I think we should have here a running algorithm, and yes, that's the case. We actually have two, because I run two, I think. So yeah, we'll wait a bit until we are waiting. Yeah, great. So this is now done. I think we're gonna get one more result because I clicked a bit too much, but there. If we click here, we can see now. Yeah, this is we have to polish this a bit, but anyway, just to quickly go through the results. Yeah, as expected, call procedure takes a bunch of time, like great majority of the time. Everything else is super quick, so it's not nothing major. So yeah, we have here hits is 1000, I think, because yeah, that's the number of nodes, and then produce. So call is produces that many nodes. For each node, there is a PageRank score, or the rank, and then when we do filter, then only the countries are left there, and then so filter is the where part, and then produce is the return part, which has 40 elements, and then limit is applied, I think, a bit before, but anyway, so they are also so these 40 results are, I mean, first order by has to be called, because you have to sort all 40 results, and then take 10 of them. But yeah, that operator is already doing that, and then it just returns 10 results. The question is, why is here 11, but in the results I think we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, we have 10 results. 10 results, and yeah, that's something also to check. So okay. I think that's more or less it that I wanted to show. Maybe, yeah, maybe just a little bit more about under the hood stuff. So let's close this for now. We don't need this anymore. But since we are here in Docker, we can just go quickly to the query modules folder and then open nxalg.py. So we're gonna install the Vim because it's very useful in general. So here, if we search for PageRank, so here is super simple stuff, because we just have a procedure, a read procedure PageRank that gets all these parameters and just they are just routed to the NX PageRank. NX PageRank is just an implementation, a NetworkX implementation of PageRank, and here we create a Memgraph dgraph. Essentially, that means we also implemented a proxy object for the whole graph. So instead of copying the whole data and passing that to the PageRank, that Memgraph dgraph is smart, and he's just fetching data from the graph without actually copying the whole graph every single time. So this is a nice optimization in general. But yeah, mostly in related to the memory usage. It still has a bunch of overhead when it comes to performance because of Python. But overall, it's a bit better than just copying the whole graph. I mean, performance is the same and memory usage is reduced because you don't have to copy the entire graph from out of Memgraph to the Python procedure. Just to quickly check where that is. So that Memgraph dgraph is actually defined in MGP NetworkX file. If we close here and MGP NetworkX, so here we have dgraph base, and here is a bunch of these proxy. So that's the whole implementation. I won't go into details now, but you can check that that's that comes with the Docker. So it's completely readable and changeable. So that's about it. What else? I think we are good here for now. Any questions? This time I'm a bit quicker. Next time I think it's gonna take more time to implement stuff in C and to explain. So if you have any last questions, please put them in the chat. Let's go back here. We actually didn't do much work here, but yeah, that's fine. We good here, and here we have Memgraph up and running. We're gonna close this. We don't need that. Maybe we can play a bit with parameters. So let's go back to here, and we have that. Let's say alpha. Let's change alpha a bit. So if we go here, and usual alpha is 0.85, so let's put 0.8. What's gonna happen? But let's leave it like that, and then just data. Now we have that as a data. Let's just rerun this to see the results and to see if the results would change if we change the D parameter. I think they should. They should. Okay, let's go back here. Actually, yeah, that's personalization. Okay, I think we have now here, yeah. So this is the result. Let's screenshot that. And now let's change this to 0.80. If we rerun this, what's gonna happen? What else we can change? I think nothing is trivial from here, so yeah, I won't go into the details. Can we actually run here? Can we actually say alpha here? I think we should. Oh, that seems almost the same, or the same. Let's go back here. 5 to 8, 5 to 7. Yeah, it's slightly different. It's not the same. It's slightly, which makes sense. So these results are slightly different based on that parameter. Let us quickly run. If we run alpha, what's gonna happen? That doesn't work. Okay, so I think we have to specify them one by one in order. So that's also fine. So we have a question. Can you please show how to run the algorithm on a subgraph if you have a set of particular interesting nodes and want to see which one of which one is the most important? Yes, let's try. It depends on the signature. So I think that's not possible in this case, because let's go back to the parameters. I mean, we have to write another procedure that will run algorithms on these nodes. But yeah, I think here it's not possible, because the PageRank from NetworkX is taking the whole graph. I mean, we are taking the whole graph in, so I think that's as is. Maybe we can do some stuff based on this interface, but I think it's not possible, because yeah, we can just change these parameters. We can change starting value, we can change the weight, we can modify the dangling nodes, and yeah, maybe I can showcase that on some other algorithm instead of PageRank, because PageRank as it is defined, it takes the global state, and the whole graph is taken into consideration. So I'll try to run that on some other algorithm, and I think I think it's possible to do that with, for example, weakly connected components. So let's jump to that a bit. So okay, let's go back here. I need to get back my comments. My comments are on another screen, so let me just pull that out. Yeah, okay, all good, all the same. So let's do weakly connected. So weakly connected component. So if we yeah, so here instead of just passing the whole, so if you take a look back, so let's go back a bit first, and then so NX algorithm PageRank. So PageRank. So here, as you can see, memgraph dgraph is constructed based on CTX, and that's context. And from that context, the entire graph is taken out, and then that's passed to the PageRank. So it's impossible to, I mean, just by not modifying this, it's impossible to run the PageRank. But yeah, just for the sake of time, I won't go and modify that. I'll just try to run stuff here. So here we have vertices and edges as lists. So weakly connected component algorithm is just returning these weakly connected components from the graph. So whatever is connected, let's put it like that. So whatever is connected will be returned. Will be like that. All nodes and all nodes in that component will have the same number. Let's say will be all nodes from the connected component will be assigned into the same group. And here we can have, because the procedure has accepts vertices and edges, we can match them prior to calling the procedure and then pass them to the procedure. So so this is called by calling call VCC get components and then something. So I'll just go back here. We can pull out that nice query that filter out all the procedures. So we're gonna rerun this, but just by putting here VCC dot get component up. And yeah, so here the procedure just gets a list of vertices and list of relationships or edges. So let me just construct a graph out of that. So, how to do that? So let's do some naive stuff first. So let's say for Russia, match n country name Russia, and then we're gonna match some relationships, return n rm. What did I do wrong? Maybe we don't have that. Okay, let's do without Russia. Yeah, it will take more because there are a bunch of edges, so I'm gonna just do this. Why is that? Have I misspelled something? Not sure. Maybe Russia doesn't have outgoing. Just a second. So if we run this, that's fine. If we add here, R, maybe all the so all the roads are coming into the Russia, which yeah, dataset is like that. So we have all these nodes here, but if we do RM, now we should have a bunch of these. Yeah, that will take a bit longer to render, but okay. And now we have a bunch of nodes and a bunch of relationships. So n is obviously Russia always, and then R are all the links between other countries and Russia. Why is happening right now? City. City in. Maybe a better would be to, let's say, to do this and limit. Sorry, I should be more familiar with the dataset, but I'm not that familiar, so we're gonna figure out. Maybe just go back. Maybe in something Paris. Again, nothing. I'm sorry. Sorry for making this silly mistake, but okay. So now we have all these things connected to Paris, all these cities, and now I think we can just pass all these algorithms, all these nodes and edges to the graph, so to the call. So if we match all that, and instead of just returning, we can do here call vcc.get components, and vertices are we need actually to make, since here is a list, we have to construct that list somehow. So how is that done? So unwind and then collect. We need to do collect. So with let's say M, which are, so M as cities, and then R as roads. We have to collect them. So we're gonna do collect R, and so collect is gonna construct a list out of these nodes, cities, roads, call weakly connected component, get components, and we have cities and roads. Okay, yield everything. Return everything. Okay, and what do we have now? So we have a list, cities components. I actually should have done that, but yield components and n components are the, let's say, take here everything and then just list components and n. So components is a list. What do we have here? We have, I think, all these. So and then I think we passed a list of nodes and edges inside, but it returned all these components, and basically, since everything is connected to everything, I think there is no like the size of the largest weakly connected component is the whole graph. Is the size of the whole graph. I think these all cities have number of component 1. So basically that's it. But yeah, more or less this is how we passed like custom nodes and edges into the algorithm. But yeah, algorithm has to be, and the procedure has to be written in a way that it accepts nodes or edges or anything else. I think that's an answer. If it's fine, yeah, please feel to ask more if something is unclear. But yeah, that's more or less it. Okay. Yeah. If there are no further questions, I think we're good for now. I hope you enjoyed. This time it was a lot shorter than the last one. The last one was really huge. I didn't expect to take that much time. And yeah, next time my idea is to scale this a bit and implement a slightly more optimal version of a PageRank, and maybe prepare also a better. I mean, obviously I have to prepare a better dataset in order to scale the whole thing, and maybe do a little bit of optimization on the whole thing. So because algorithm can have a bunch of optimizations and also can be parallelized. So yeah, that's my idea for the next time. And probably it's gonna take more time. So let's say a couple of hours to showcase all that. And yeah, that's it. Thank you very much for watching. I hope you enjoyed, and yeah, see you next time. Bye bye.